Hello, guys. Welcome to Ramta Solutions. Welcome to Organic Molecule Series. Today, the lesson focuses on alkenes. Right, and this is all you need to know about alkenes. So, alkenes, you will see them with a double bond. Okay, now let's get into it. Now, how we going to structure this video is like this. One, we are going to give you a brief of what alkenes are. Then we're going to proceed to show you how alkenes are named, of course, using the IUPAC name, but we're going to show you the procedure. Then we're going to conclude this video with drawing structures and perhaps naming alkenes if given a structure. Okay, all right. So let's get into it, guys, and I hope you will enjoy this video. So, like we said in the opening slide, we saw that alkenes have a double bond. So they are hydrocarbons, unsaturated hydrocarbons for that matter. They are unsaturated hydrocarbons with at least one double bond. Remember, they may have more than one double bond. It is not that they should only have one double bond. They may have more than one double bond. Okay. Now, alkenes, they are more reactive than alkanes. Okay. And when you name alkenes, the name ends with ene, which we will, or rather, which we are calling in. Okay, the name ends with ene. For example, you will have ethene. Okay, so this is an unsaturated hydrocarbon that is double bond, right? And this is for unsaturated hydrocarbons with two carbons, and that is a double bond. Okay, this is an ethene. All right, this is an ethene. Okay, so of course, this ethene is your simplest alkene. Okay, is your simplest alkene. You normally call it ethylene. Okay, you normally call it ethylene. The family of alkenes have a general formula CN2HN. If you remember, because of, or rather, if you look at it, because of the double bond, this will mean that alkenes are two less hydrocarbons than alkanes. If you recall, alkanes had general formula of alkanes had general formula CnH2n plus 2, right? So now we are saying these ones have two less hydrocarbons, two less hydrogens because of the double bond. Hence it is 2n and not 2n plus 2. Okay, it has two less hydrocarbons than alkanes. It has two less hydrocarbons than alkanes. Right. Now, because they have two less hydrogens, this is giving us an indication that they will undergo addition reaction. Okay, they will undergo addition reaction. Okay, they will undergo addition reaction. All right. Okay. All right. Perfect. Now, another thing that we also need to mention is their solubility. But when it comes to solubilities and boiling points, we're not going to dwell much on them. We're just going to just point them. We're going to deal with them when we get to physical properties of organic molecules. And that is basically the 10th video from now. Okay, so what we know about alkenes is that they are insoluble in water. Why? Because of the weak van der Waals forces. When we talk of van der Waals forces, I remember you guys covered them in grade 11. Do you remember? We covered them in grade 11. All right. But we are going to look at them later when we talk physical properties. For now, it is just for you to know these properties, that most alkenes are insoluble in water. And alkenes also, they dissolve in organic compounds. Okay, they dissolve in organic compounds. Okay, and we have said, remember, that they have weak van der Waals forces. This somehow makes them slightly rather gives them boiling points that are slightly less than those of alkanes. Okay, because of them having weak van der Waals forces, they have boiling points that are less than those of alkanes. Okay, all right. Now, let us imagine the uses of alkenes. Let us imagine the uses of alkenes. I want to show you something that you are not aware of. The ripening of fruits and vegetables. That is alkenes in action. Okay? Do you want another example? The production of plastics. Yes, we use alkenes as monomers to produce plastics. Okay? They are precursors of plastic production. Okay? Even in pharmaceuticals, they use plastics. Sorry, they use alkenes. Okay? Even in pharmaceuticals, they use alkenes. When it comes to wood treatment chemicals, there is application of alkenes. Remember, our wood, if you don't treat our wood, they are susceptible to insect infestation. There's this insect that likes feeding on wood. If you want to avoid that insect feeding on your timber, try to treat your wood with this chemical. Okay? And lastly, if you look at your clothes, even your carpets, most textiles, alkenes are in place. Okay, alkenes are in place. So these are some of the uses of alkenes. Okay, guys, these are some of the uses of alkenes. Now, the naming system used by to name alkenes, or the nomenclature used for alkenes, is of course recommended by the IUPAC. Okay, so we use the IUPAC system. Hence, your exam will be telling you what is the IUPAC name of the following molecule or the following structure. Okay, so the IUPAC says when we name organic molecules, one, you recognize the functional group. Because this video is about alkenes, you recognize that it's a double bond. The double bond is the functional group. Remember, it is the double carbon-carbon bond, right? It is the functional group. Then you find the longest continuous carbon chain. What is this? This is maximum number of carbons, okay? This is maximum number of carbon atoms. That is your longest continuous carbon chain. Okay? Then, when you start numbering, you begin with the end, with the carbon rather, with the carbon that is nearest the double bond. Okay? You begin with the end rather that is nearest the double bond. So that carbon that you're gonna say you are the first carbon, you move left or right or you move up, and however, that carbon must be to the end that is nearest the double bond. If your double bond is on carbon 3, say you're counting from left, and then when you count from right is on carbon number 1, it means you must begin with the one where the double bond is carbon number 1. Or if the double bond, say you moving from left to right, the double bond is on 3, and when you move from right to left, the double bond is on 2. It means that you're gonna take the one off, moving from right to left. Okay? Because you're gonna take the lowest number. Right. Remember, begin with the end nearest the double bond. Then you will name its substituents. It's important to know your substituents. Your substituents, you remember them. In place of hydrogen, it is those molecules, okay, or ions. Not molecule, it is those ions. Then, what you're going to do, how you name your organic molecules, you're going to, one, begin with the number where the number of the carbon where the substituent is. If your substituent is on carbon number 3, you're gonna start 3, let's say it's 3 ethyl blah blah, so it's gonna be 3 ethyl. If it's on 4, it's gonna be 4 ethyl. So you begin the name with the numbers of the carbon where each substituent is bonded. Okay, now it happens that you have more than one substituent. When you have more than one substituent, what do? You use your prefixes di, tri, tetra, and penta. But hold on, if you have more than one substituent, especially different substituent, you will have to list them in alphabetical order. Okay, list them in alphabetical order. And now, if there are 2 or more of the same kind, this is when you use the prefixes di, tri, tetra, penta, and so on. Okay, remember, if you have substituents of the same kind, you use di, tri, tetra, penta. And if you have different substituents, you list them alphabetically. Okay, you list them alphabetically. All right, perfect. Now, and by the way, I almost forgot. Even the double bonds, when you name your alkenes, you must show the position of the double bond. It's important to show the position of the double bond. Of course, this will not apply for ethene and propene. All right? All right. Now, these are your alkenes. Now, for carbon 2 and 3, the names are simply ethene and propene. Now, 4 carbons and more, the names could be different to what you are seeing here, because the double bond can be on carbon number 2, number 3, number 4, wherever, right? Depending on the size of the molecule. These are just the simplified. And I also need to tell you, the naming here can also be but-1e. This naming implies that the double bond is on carbon number 1. Okay, it can also be written in this form. It is also okay. All right, and you will see this later, where we're saying it has more than one name possible. You will see it later, but these are the best we can think of because they have the highest boiling points. Okay. All right. So while we are on the names of alkenes, the first 3 alkenes are gases at liquid temperature, and the rest are liquid at room temperature. I repeat, the first 3 are gases at room temperature, and the rest are liquids at room temperature. Okay, perfect. By now, you know your alkyl substituents. Normally, when you were dealing with alkanes, it was CH4, CH3, CH3. But now with alkyl groups, it is 1 hydrogen less. Okay, it is your alkanes with 1 hydrogen less, or with so alkyl groups are alkanes with 1 hydrogen less. Okay, normally we would say methane, ethane, propane, butane. But now we no longer say that. We say methyl, ethyl, propyl, butyl. Why? Because they have 1 less hydrogen. Okay, they have 1 less hydrogen than alkanes, and this we call them alkyls. Okay, now you can see that we have propyl and isopropyl. So with propyl, your longest chain will be bonded to the carbon on the end here, but with isopropyl, the longest chain will be bonded to the central carbon. Okay, it will be bonded to the central carbon. You will be using these 3 mostly, but it's also important to know these 2. Okay, it's also important to know these 2, but you will be using these 3. Okay, all right. Halogens, for alkenes, we're not going to talk about them. Now, let's begin now by drawing our structures. Let's look at this one here. So you ask yourself, how many carbons does it contain? 2. When it contains 2, what do we call it? We call it F. Oh, what is the functional group? Double carbon-carbon bond. So that's an alkene. The suffix is ethene. Right, the suffix is in. So the name is ethene. Okay, the name is ethene. Right, the name is ethene. Happy? Great. Now let's try this one here. 1, 2, 3, 4. Let me try it here. Let's try it here. Look at, oops. So look at this. Yes. Okay, now this one, functional group, we recognize that it is at least one double carbon-carbon bond. So the suffix is ene. Ooh, that means we also need to locate the position of the double bond. Where is it? Hold on. We need to start numbering the carbons. We begin with the end nearest the carbon bond. So let me start from the left. 1, 2, 3, 4. Even if I had started from the right, it was still going to be the same, isn't it? So this is in position 2. How many carbons is our longest chain? 4. So it's butene, or you can say it's 2-butene. Okay, or you can say it's 2-butene, right? And this is your alkenes. Okay, now let's go. We're gonna try this one here. Now we have 2,3 dimethylhexene. Oops, dimethyl 2-hexene, sorry. Dimethyl, let me write it like this, hex 2-ene. So this one, guys, can also be written in the form, it can also be written in the form 2,3 dimethyl 2-hexene. Okay, it can also be written like this. All right, good. Now let's go. The longest chain here is hex, which is 6 carbons. So 1, 2, 3, 4, 5, 6. Where is the double bond? In the second carbon. I can draw it here, but let me just draw it here because I want to start naming from the left. Oh yeah. And where are substituents? On carbon 2, we have methyl. On carbon 3, we also have methyl. Do we have any other substituent? No, we don't. So let's just fill in all the 8 hydrogens. This color is actually nice. I should have used it all along, isn't it? So you can see now how we label them. 1, 2, 3, 4, 5, 6. Can you see where's the double bond? On carbon 2. Where are substituents? On carbon 2 and 3. And what are those substituents? Methyl. We're good, isn't it? We are good. All right, now let's head to the next one. Now let's try. Now let's try. I'm gonna try this one here. Let me draw its condensed structural formula. CH3 CH2. Okay, what is this? Ooh, I see it has 3 carbons. It doesn't look like it has a substituent. So 3 carbons. This is gonna be propene. Okay, this is gonna be propene, guys. It's gonna be propene. Okay, Now, in case you're wondering how to draw the structure, the first carbon has 3 hydrogens. The second carbon has 1 hydrogen. The third has 2 hydrogens. This gave me an indication that there's a double bond between these two. Why? Because I know normally it's CH3, CH2, CH3. But now you can see that there's 1 hydrogen missing, there's 1 hydrogen missing here. Remember I said when you have 2 hydrogens missing, you have an alkene. Okay? And this is propene. And this is how you draw the structure of the alkene. This is your condensed structural formula. Okay, moving on. We are going to try this one here. Let's see. We have 2-ethyl bute 1,3 diene. So with this one, it says to us we have 2 double bonds. One double bond is on carbon 1, one is on carbon 1 and the other is on carbon 3. What is the longest chain? The longest chain is bute, meaning it has 4 carbons. Let's see. Moja, mbili, tatu, nne. So first double bond is on carbon 1 and the other is on carbon 3. So as you can see, this is my 1, this is my 2, this is my 3, this is my 4. Where is the substituent? The substituent is on carbon 2. Carbon 2, which substituent is that? CH2, CH3. This is ethyl, isn't it? Good. So this is ethyl, and perhaps maybe let me draw it in this way, or those that might need this. Okay, maybe let me draw it in this way. Yeah, it's better. Uh-huh. 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 Yeah. Oh yeah. So this is 2-ethyl bute 1,3 diene. As you can see, I started numbering from the left. This is 1, this is 2, this is 3. And this is how you draw this structure. Okay, this is how you draw this structure. Happy? Perfect. Now, we're going to try another one. Let's see. Let's try condensed structural formula. We'll name it as well CH3, C, open bracket, CH3 close, CH, CH2, CH3. Remember what I said to you? Normally it's CH3, CH2, CH2. There's a double bond here. Already I can see what is the longest chain. 1, 2, 3, 4. Is it 4 or 5? I think it's 5. Is it? Let me see. 1, 2, 3, 4, 5. I think it's 5. And I see there's a methyl substituent rather on the second carbon. So I think this will be 2-methyl pent 2 in. Remember I said it looks like 1 hydrogen is missing on adjacent carbons. On 2 adjacent carbons, right? On both of them, isn't it? Good. Now let me show you a structural formula of this guy. First carbon, you have 3 hydrogens. Second carbon, you don't have a hydrogen, you have an alkyl, CH3. Right? Okay, I might as well just put the H's. And then third carbon, you have only 1 H. You must be a double bond. And this completes 4 bonds between this carbon. Happy? The one after 2 hydrogens, followed by the one with 3 hydrogens, and this is complete. How do we start numbering? I'm going to start numbering. Remember, with the end nearest the double bond. you go this way, 1 2 3 4 5, or 1 2 3 4 5, or 1 2 3 4 5. It seems if you take this route or this route, you are okay. Either of them will give you 5. So I will start numbering here. Let me change the color. So it'll be nngwe, pedi, tharo, nne, tlhano. Isn't it? Now, this is 2-methyl pent 2-ene. Remember, you can also call it 2-methyl 2-pentene. It's also okay. But the first name is preferable. I'm not saying the second is wrong. It's also okay. All right. Perfect. Now, let's try. Let me try this one here. Let me try this one here. Maybe I should give you one last. I'm gonna draw it. I'm gonna give you a condensed as well. CH3, CH, CH, CH2, CH. I like it when there are people whose English accent they say H. I like it. I wish I can also say H, but hey, I'm not used to it. CH3, H. And indeed it makes sense, because if you say H, I have a problem with H. Like H. And those ones that say H, I like it when they say H, because it helps with reading when you come to some terms that you do not know. For example, you're going to come to this term here. It's called hall, isn't it? It's going to be called hall. And as we say H, I don't even know why, but it's okay. Let's proceed. So let's look at this molecule. Already on the condensed structural formula, I recognize a double bond on this carbon. So it seems I'm going to start numbering from this end. So it's going to be 1, 2, 3, 4, 5, 6. It seems the longest chain is 6 carbons. All right. And then I see a substituent as well. Where's that substituent? On carbon 5. I, for one, see 5-methyl. Where's the double bond? I said on carbon number 2. And the longest chain is hexene. But remember the preferable 5-methyl hex 2-ene. Let's draw the structural formula of this guy. CH3, the first one, right? The second one has 1 H. It must be a double bond. The second one has 1 H, of course, and the one after has 2 H's. The one after has 1 H and an alkyl substituent, CH3, isn't it? Followed by one with 3 hydrogens, 3 H's. Okay, or 3 H's. We say H. All right. Now, can you see this? Let's see now. 1, 2, 3, 4, 5, 6. So the name is correct, isn't it? So with that being said, we have come to the end of our video, and I would like to say to you guys, we thank you. Re a leboga. Ro leboga ngamanda. Enkosi. Asante. See you next time when we look at alkynes. All right, guys, if you enjoyed this video, remember to subscribe and share with your friends. So, bye-bye.